This is review for exam 3. What we need to do here to find the absolute min and max, we need to find the first derivative, which is 8 minus 2x, set it equals 0. Then solve for x by subtracting 8, dividing by -2. So I got the critical number. This is called critical number. Okay, and then we need to evaluate the function. For part A, there's only the critical number actually. There's no endpoints of the interval, see? So what we need to do is, this is going to be either min or max. We don't know. But to do so, we find the second derivative, which is 0 minus 2, -2, less than 0. Less than 0 means it concaves down. So this means there's an absolute maximum at x equals 4. How about part B? Part B, we need to find f of 4, f of 1, and f of 6. F of 4, it's 8 times 4 minus 4 squared. F of 1, it's 8 times 1 minus 1 squared. F of 6, 8 times 6 minus 6 squared. Let's see what we get. 32 minus 16, that's 16. That's 8 minus 1, 7. 48 minus 36, 12. Notice this gives us the max. So there's an absolute maximum at x equals 4, and the least is 7. Absolute minimum at x equals 1. Absolute minimum at x equals 1. Another example, let f of x equals x cubed minus 3x plus 6. Part A, find critical numbers. Find critical numbers. We need to find the interval. What is it? Increasing and decreasing. Find interval about concavity. What is it? Concave down, concave up. Find point of inflection. And probably graph it. How do we find critical numbers? To find critical numbers, we set the derivative equal to 0 or does not exist. So let's find the derivative for this one, which is 3x squared minus 3. When you set it equals 0, divide everything by 3. Factor. So we got x equals 1 or x equals -1. Those are the critical numbers. Critical numbers. Okay, so we can move on. So for part B, to know when is it increasing, when is it decreasing, put that on the number line, the critical values that we got. And you can select testing points. Select x equals 2. and substitute into the derivative. So here there's infinity, but this is for f prime. This line belongs to f prime. So you must substitute in f prime, not in the original function. So when you substitute 2 in, you're going to get a positive value. If you substitute 0, you're going to get negative and positive. So it's increasing, decreasing, increasing. So it's going to be, the graph is going to be increasing from negative infinity to negative 1, union 1 to infinity, and decreasing from negative 1 to 1. Part C, concavity. So we found f prime, 3x squared minus 3. We find the second derivative, which is 6x. So when the second derivative bigger than 0, this means 6x bigger than 0, x bigger than 0. That's when it concaves up. The second derivative less than 0, 6x less than 0, x less than 0 concaves down. So it concaves up from 0 to infinity, concaves down negative infinity to 0. Inflection point. So to get inflection point, you need to set the second derivative equal to 0 or does not exist. If you divide by 6, you get 0 over 6. So x is 0. That's not enough. We need to substitute back into the original function to find the y value. So if you put that into the original function, x cubed minus 3x plus 6, that will give us 6. So the point I, 0, 6, is inflection point. E, graph it. So all the stuff we did will help us to graph this. Inflection point means the graph's going to go through it. So say it's here. That's when the graph changed concavity. Critical numbers that we found were 1 and negative 1. You can find their corresponding y values by substituting into the original function. That would be 1 minus 3 plus 6, 4. Negative 1 plus 3 plus 6, 8. So 1, 4. Negative 1, 8. Remember what it says. It's increasing from negative infinity to negative 1. I don't know, maybe like this. And then it went through this. Decreasing between negative 1 and 1, and then 1 to infinity increasing again. Now we need to check the concavity. It says concaves up when x bigger than 0. Yeah, I can see it. So from here on it concaves up. And it concaves down from there on. That's the graph. Next problem. Find asymptotes as we did last time. Y equals 2x, x squared minus 4, 5x minus 1, x squared plus 9. So for the asymptotes, what we have, we set the denominator equals 0, solve if possible. We get x equals 2 and x equals -2 as vertical asymptotes. Notice the top is less than the bottom. So then automatically y equals 0 is a horizontal asymptote. That's for this one. Similarly, for this one, y equals 0 is a horizontal asymptote. HA means horizontal asymptote. Now, if I want to set the denominator equal to 0, this will never be 0. No vertical asymptote. Next one is maximizing this. So what do? We solve for y from here and substitute it into the q. 30 minus 3x. That would give us 30x minus 3x squared. That's a function in x now. So we need to find its derivative, 30 minus 6x, and set it equals 0. That will give us x equals 5. So I found the value of x that would maximize this. And to make sure we are on the right track for maximizing, we find the second derivative, -6. That's less than 0. Means it concaves down. And that confirms by the second derivative test, there's a maximum. So from the x value, you can find the y value by substituting in here. 30 minus 3 times 5, that's 15. Then the maximum value of q, x is 5 and y 15, which is 75. There's another one here similar to it if you want to try. So we do the same thing. We can solve for y here by subtracting x on both sides. Divide by 2, 25 minus 1/2 x. Now we can get q equals x times y squared. That's one way to do it. Or if you like, look, you can solve for x. It's easier, no fractions. And substitute that in. So then q would be, instead of x, put 50 minus 2y times y squared. 50y squared minus 2y cubed. Then q prime is 100y minus 6y squared. Take a y out, you got 100 minus 6y. So either y is 0 or 100 over 6, which is 50 over 3. So I don't know which one is min, which one is max, so I'm going to find here q double prime, which is 100 minus 12y. We try to find this at 0 first, and then we find it at 50 over 3. At 0, it's 100 minus 12 times 0. That's 100. At the other one, 50 over 3, 4, that's going to be negative. 100 minus 200, negative 100. So this one, bigger than 0, means concaves up. So there's a min here. There's a max here. So it will be maximized because they want us to maximize it. Maximized at y equals 50 over 3. And you can substitute this back in here to find the x value. 50 minus 100 over 3. 50 over 3. Next one. For this example here, we would like to maximize the profit. So to do so, we need to find an expression for the profit. Capital P of X, remember profit is revenue minus cost. Revenue minus cost. Revenue is given, minus the cost is 1.1x squared plus 10x plus 80. We need to multiply the negative sign in. So that gives negative 0.1x squared plus 100x minus 20. So I found an expression for the profit. And we need to maximize it. Maximize it means derivative equal to 0. Subtract 100 on both sides. You get 100 over 0.2. If you multiply, or you try it on the calculator, you get 500. So that will lead a maximum, and you can see it's maximum if you find the second derivative. It's always less than 0, concaves down, so it's maximum. So there will be a maximum profit at x equals 500. And if we need to find what that maximum profit, all we have to do is substitute P of, in here, P of 500, negative 0.1, 500 square, plus 100 times 500 minus 20. So that would give us 24980. So $24,980 profit for selling that X number of units. X equals 500 units. Anyone has any questions you would like me to go over?